There are a couple non-systematic naming conventions that you really should know in organic chemistry. These will come in very handy. First one comes about when you have a propyl substituent or 3-carbon substituent. When you have a group attached to the N carbon of a propyl group, use propyl as a prefix. Sometimes people actually write this as N-propyl. The N is completely optional, but it just emphasizes the fact that it's a linear straight chain and the group is attached to the end of it. But the propane molecule itself has two types of carbon. If the iodide is attached to the middle carbon, then you get isopropyl iodide. When you go up to 4 carbons, it gets a little bit more complicated. There are 2 isomers of butane, like so. So you have 2 isomers. Each of these 2 isomers has 2 different types of carbon. A, B, C, and D. We want to fill in the other ones. That's a C, that's a D, these 3 are B's. Okay. So if we're going to attach an iodide to any of these carbons, if we attach it to one of these A's, we get a different molecule than if we attach it to a D. And so there's a naming convention out there to tell you exactly which carbon it's attached to. If it's attached to the N carbon of a straight chain, it's just the base name, butyl. This is butyl iodide. Or you can even call it N-butyl iodide. Now you have 2 more. We have sec and tert. Sec is short for secondary. Tert is short for tertiary. What a secondary carbon is attached to 2 other carbons, directly attached to 2 other carbons. So we take a look at this. Carbon C is only attached to 1. Carbon D is attached to 2 carbons. That's a secondary carbon. Carbon B is attached to 1 carbon. Carbon A is attached to 1, 2, 3 carbons. Carbon D, if you notice, is the only secondary carbon amongst these different types of carbons. This molecule here is sec-butyl iodide. Tertiary, is a carbon that's attached to 3 different carbons. The only tertiary carbon amongst these 4 different types is carbon A, right here. This is referred to as tert-butyl iodide. So we covered carbon C, carbon D, and carbon A. The only one we haven't covered yet is carbon B. This last remaining one is the isobutyl case. Isobutyl iodide is when we attach it to one of carbon B. And you can kind of see how isopropyl and isobutyl are related. They both have this sort of this Y shape. The difference is isobutyl has an extra CH2 in it. Okay. If we put an extra CH2 at the tert-butyl side, so we have a tert-butyl group here, then we have the extra CH2. We get another very, very important chain. This is the neopentyl group. This molecule is called neopentyl iodide. Neopentyl groups, such as neopentyl iodides, are amongst the most boring molecules out there because they virtually do nothing. They're very, very unreactive. So we'll get to these in a couple weeks or so. Okay. There are two more names that you should be familiar with that are very confusing. They have to do with benzene rings. This molecule here is called iodobenzene, or another way of calling it is phenyl iodide. If you add a CH2 between the benzene ring and your substituent, you form the benzyl group. It's just an unfortunate name. Keep in mind, the ring itself is called a phenyl ring. But when you add a CH2 to it, it becomes a benzyl group. So, it's unfortunate. Blame some chemists that are long dead for this nomenclature flap up, but it's now part of the knowledge. You need to know the difference between phenyl iodide and benzyl iodide. Big difference between the two. Phenyl iodide has the iodide directly attached to the benzene ring. It's directly attached to an sp2 carbon. The benzyl iodide has the iodide attached to an sp3 carbon. Huge amounts of difference in terms of reactivity and properties.